Hello everyone. In this video, let's go ahead and do another practice problem. Let's just jump on in. So it says the director of FitTrack, a company that produces wearable fitness trackers, is investigating how often users achieve their daily step goal of 10,000 steps. Historically, about 20% of users meet their step goal on any given day. To evaluate the proportion of users reaching their goal, the team randomly selects 100 users and records whether each user reached their step goal. The team is also reviewing the way that they gather their data to ensure the sampling method remains valid and representative of their user base. Okay, so if we jump in here, let's look at a couple of these numbers that are being provided and see if we can get any clues of what's going on. So the first number that we get is just this as like their step goal of 10,000 steps. And if we keep reading, it looks like that we're not actually measuring how many steps people are taking. We're just saying, did you hit your goal? Kind of yes or no. And then we get this historically about 20% of users meet their step goal on any given day. Now, that is some key information that we want. And that key phrase historically typically is used when we are talking about like population parameters. So we've got this population parameter, pi, is equal to 20%, so we'll do equals 0.2. And then it also gives us a sample size when it says to evaluate the proportion, we take a random sample of 100 users. So I want to say n is equal to 100. Okay, let's look at our question. So the first one says is what is the standard error of the sampling distribution with respect to proportion in this scenario, given the sample size? Like, okay, let's take a look at this. So when we are just looking at this standard error, one place that we can look at is when we are dealing with like our numerical data with respect to proportions. And let's kind of zoom in down here and let's see what we can see. So we want to scroll on down and let's go over to some of these key variables in our proportions section. Hold on, let me scroll over. So we got our key variables, and then if I scroll all the way over to the left, you can see that this is for categorical proportions. Okay, come back on over, and we see that if we want our standard error or the standard deviation of the sampling distribution with respect to proportions, this is what we are looking for. This is just the square root of pi times 1 minus pi divided by n. So we've got all of that. We can say that this is sigma underscore p, or standard error, and we are just going to do sqrt, the square root of pi times 1 minus pi, and we can divide, oopsies, pi, and we can divide by the sample size, end our parentheses, and we hit enter, and we get 0.04. So we get this value right here, b, and just to double check, if we want to, we can do a right click in here and we can increase the number of decimal places to make sure that it's not just a rounding problem. And it's like, nope, it really is 0.04. So we got question number 1 all taken care of. Scrolling on down, question number 2. What is the probability that the sample proportion of users who achieve their daily step goal is less than 15% given the sample size? Okay, let's draw a quick little picture real quick. So I'm just going to draw, and what we can see is that, let's come across just like this, and we've got kind of our distribution here. We have our normal distribution centered on our population parameter. And if we kind of look up here, we can see that it's centered on the population parameter of pi. And we've got our standard error determining where that inflection point is. So we know that this is going to be 0.2. And we know that this distance to the standard error is 0.04. And so we know that this is going to be, this point right here is going to be 0.16. And we want to know about where 0.15 is. So let me go ahead and change my color real quick. And so 0.15 is going to be something like this. And it says, what's the probability that it's going to be less than this 0.15? So we can just shade this in. We can see that this is probably going to be something pretty small, like maybe 10%-ish, somewhere right in there. Maybe 15%, something close to that for this area. Now we can actually calculate out this proportion. If we go ahead and scroll down, or let's actually put in our p critical too. So our critical proportion is 0.15, the one that we're interested in. Let's go ahead and calculate out a probability here. Let me scroll on over. And we see that, hey, if we want the area less than, we just type in this, this equation. So we want to know the probability that the proportion is less than 15%. And let's go ahead and type that in. It's going to be norm dot dist, parentheses, our p critical, which is just following our results over here, p critical, comma, our pi value, comma, our standard error, comma, and then we type in the word true. And we hit enter, and we get about 10.5% or 0.1056. So we were able to snag that value. All right, perfect. So we were able to get our area of being less than 0.15 here, and that's our probability that we're interested in. All right, question number 3. FitTrack's director is concerned about the sampling method. To simplify logistics, they decided to survey randomly selected individuals so that roughly 50% were men and 50% were women. What type of sampling method is this? Okay, so we've got a bunch of different versions of sampling here. We just have simple random sampling, we have systematic, cluster, and stratified. If we go to kind of page 1, we kind of have a few, well, just a little bit on this. And we can look to see, like, simple random is just everybody has an equally likely value of getting selected. Systematic is like where we line people up and we take every like fourth. Cluster is where population is broken up into groups, and then we randomly select the groups, and every member in the group is measured. And then stratified is some demographic is selected, and the sample matches the ratio of the selected demographic. And that's what we've done here. We've done stratified because we are looking at men and women. We know that our population is roughly 50-50, and so that is what we are looking at for our stratified sampling. Okay, question 4. So it says, suppose FitTrack increases the sample size to 400 users. What impact would this have on the standard error of the sample proportion? And we would say that, okay, as our sample size increases, what's going to happen? Well, let's take a look at our standard error calculation here again. So if we go over to our standard error, scroll over, as the sample size increases, this standard error is probably going to decrease. We can also just check in here. Let me just double check and change this from n equals 100 to 400, and let's see what happens to our standard error. And our standard error decreased by half. So it definitely got smaller from where we were at a sample size of 100. So the standard error will decrease. Let's go ahead and highlight that one. And let's do, question number 5. So it says the team wants to construct a 95% confidence interval for the proportion of users who meet their step goal, which is the best describes the interpretation of that interval. Okay, so let's say that we want to take this, and instead of just saying that, hey, we think that the true value actually is 20%, let's say it's like, well, from this data, what would happen if we calculated out a confidence interval? And when we do these in repeated sampling, about 95% of confidence intervals constructed will contain the true proportion. So it's not that 95% of all users are going to fall in that, and there's not a 95% chance that the true proportion is inside the interval. Even though that kind of feels right, we're not giving probability to the true proportion being inside the interval. We are confident, we're 95% confident that the interval has captured the true proportion. Slight nuance there, but important to know. And then if we look at the last one, the confidence interval shows the proportion of users who actually met the step goal in the sample, and that's not true as well, because we're looking, again, at averages of we're really looking at the true proportion. And so this one, in repeated sampling, about 95% of the confidence intervals constructed will contain the true proportion. Great. So that's kind of how we go through and do this one. Other questions that might be asked as well is like if we are interested in quantiles. So let's do one more. Let me type out one more question real quick. So we'll do a question number 6. Question 6. And we can do suppose we want to know what the top, we'll do like the top 15% of results would be. In other words, I'm saying that's like, okay, if we are looking at this top 15%, or I could also say what the 85th percentile, the top 15 results would be, and the instead of saying like of results would be of, we'll say people who met their step goals. Okay, so if I draw on this one, if I want to know where the top 15% is, let's shade it in. So what it's saying, it's like, I'm interested in shading, get to this top 15%, and I want to know where is this critical point. Okay, we can go at this two ways. If we use the percentile with 85th, that would be the cutoff for the bottom percentage. We're coming from 85% and we're shading 85 until this way. That would be 85. This 0.85, sorry. Or are we over here and looking at the top 15%, which is 0.15? You can do either, and let me show you how you can do either and how you'll get the same answer either way. So we are looking for the top 15%, which is also the 85th percentile. Percentile. And let's grab these values. So first of all, I'll start off with the top 15. So top percentage is just going to be equal of the norm dot inverse of 1 minus the probability of 0.15, comma, pi, and then comma my standard error. And that would give me 24% of people would be the top 15% of when people who met their step goals. The 85th percentile is very similar. It's just the norm dot inverse of 0.85, comma, pi, comma, standard error. And it's going to give you the same thing. Why? Well, what's 1 minus 0.15? It is 0.85. So there you go. That was just kind of a little bonus problem for looking at our question 6 if we want to do a percentile question using our proportions. Best of luck.